Hello everyone. We are going to continue with our lessons today. We are on section 1-6, midpoint and distance in the coordinate plane. Please take out your notes if you haven't done so already. First of all, our lesson objective for today is to develop and apply the formula for midpoint. Also, use the distance formula and the Pythagorean theorem to find the distance between 2 points. A coordinate plane is something that you've used lots and lots of times before in previous years. It's just where you have the x and y axis and you're able to plot a point on the graph using an x and y. In our vocabulary section today, we need to talk about a right triangle. And a right triangle has a couple of legs and it has a hypotenuse. The legs of the triangle are the ones that are the sides that are attached to the right angle. Attached to right angle. And these two sides in this right triangle are AB and BC. The hypotenuse of the right triangle is the side opposite the right angle. Opposite right angle. And in this case, my hypotenuse is AC. Okay? So this is a leg, this is another leg, and this is a hypotenuse. Okay. Midpoint formula. Where's the middle point between -1, 2 and 3, 2? I'm so glad you asked. Let's talk about that really quick. Here I have a coordinate plane, and we're going to try and find the middle point between these two segments here. So let's see. This length is 1, 2, 3, 4 across. So it stands to reason that if I went 2 across and put a point there, that would be the midpoint. The midpoint in this case then is 1, 2. So let's write that down here. 1, 2. Okay. What is the middle point of -2, -2, and -2, 4? So glad you asked. Let's see if we can figure it out. So the midpoint between these two, let's count how long this is. 1, 2, 3, 4, 5, 6. So it stands to reason that if we went 1, 2, 3, we would find the middle point. So that is -2, 1. Okay, how about the middle point between these 2 points, -1, -2, and 3, 4? So here we have this graph, -1, -2, and 3, 4. So let's see how, oh goodness, this is going on a diagonal. It's a little bit harder. But let's see if maybe we can find the middle point between it. Okay, so if we go, let's see. We go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. Ooh, okay. If we go up 1, 2, 3, because remember it was 6, so we're going to go up 3. And if we go over 2, because it was 4, ooh, I wonder if that's it. So let's see. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Yay, we found it. Awesome. So this is 1, 1. Okay, how can we do that without counting, though? How do you find the midpoint without counting? Well, as it turns out, take a look. If we're going horizontal, the 2's stay the same. And what we did here is we had a -1 and a 3, and we found the middle. We found the average, right? -1 plus 3 divided by 2 is 1. How about this one? -2, -2 stayed -2. But this one was -2 and +4, and if we found the average between those two, it's also 1, right? -2 plus 4 is +2. 2 divided by 2 is 1. And so that's what ends up happening here. We find the middle. We find the average. So that's how we can do it. We take the average. Okay? That's how we find the midpoint. So the midpoint formula, if you have any 2 points, is the average of the x's and the average of the y's. That's how we find the midpoint. In the book, it has it a little bit fancier. And what it says in the book is if you have 2 points, x1, y1, that means any point on the graph, and another point, x2, y2, then you can find the average by adding these together, x1 plus x2 over 2, and adding the y's together, y1 plus y2 over 2. And there you have it. Okay. Distance formula. The distance between 2 points is, here's our fancy distance formula. Great big old square root. Parentheses, parentheses squared, plus parentheses, parentheses squared. And you put minuses inside here. And then what goes here are your x's, and it doesn't matter which order you put them in. I think the book has x2 and x1, but it doesn't matter. And then you put your y's in the other spot, y2, y1. That's a crazy formula. You're going to have to memorize that. But I tell you what, it will get easier as you work on it, and it's not so bad as it looks. Now, you might be wondering to yourself, where did they come up with such a crazy formula? So glad you asked. It actually comes from the Pythagorean Theorem. So the Pythagorean Theorem is something that I know you've learned before. And the Pythagorean Theorem is if you have any right triangle, so it only works for right triangles. If you have any right triangle, you can have a formula that does something like this. You have a squared plus b squared equals c squared. Or if sometimes people get all worried and stuff about the a squared and b squared, because they get all concerned about which one's A and which one's B. But it doesn't matter at all. So you could have this one over here if you wanted to. You could also have this be B squared plus A squared equals C squared. The only one that it does make a difference on is where the C is. The hypotenuse has to be the one that it's equal to. And if you write it like this, then it would be leg squared plus leg squared equals hypotenuse squared. Okay, and I'll show you now, we're going to go down below. Okay, so go all the way down to the bottom of the page here. We're going to do a problem where you have to use the distance and the Pythagorean Theorem formula to find the distance, because you're going to be doing this in your book work and also in the review for mastery. So let's do an example of this. This is one that students really need to know how to do. So we're going to do these 2 points right here. We're going to use our distance formula and we're going to use our Pythagorean theorem. So use the distance formula. So first of all, we're going to, if we're using the distance formula, then what we need to do is plug it into the great big old square root, parentheses, parentheses squared, plus parentheses, parentheses squared with minus, minus. And so we're going to plug in our x's. And so we have -2 and +2. And it doesn't matter which order we put them in. I'm going to put them in this order. So that's a -2 here, because negative and negative, when you subtract a negative, it actually becomes a positive. And I like dealing with positive numbers more than negative numbers, so I'm going to do it that way. This next one, 3 and -2, I'm going to go ahead and do it that way. And again, become positive. So now we have 2 plus 2 is 4, 4 squared, so that's 4 squared, plus 3 plus 2 is 5, and 5 squared, or so we have 5 squared, so that is 16 plus 25, 41. Okay, so now what you can do is you can, oops, square root of that, square root of 41. We can take our calculator and we can find out what the square root of 41 is. So I'm going to use my square root button here and do 41 equals, and I get 6.4. So This is about 6.4. Now we're going to use this, we're going to do the same problem, but this time we're going to use the Pythagorean theorem. Okay, Pythagorean theorem is when you have to graph it first. So we're going to graph it. So -2, 3, and +2, -2. So here we graph it. So here we have our A, which is -2, 3, and B, which is 2, -2. Okay, so there we're going to connect the dots. Okay, now, in order to use the Pythagorean theorem, we need to use we need to find our triangle that's hidden. So I'm going to do my triangle this way. You can instead do your triangle up here if you want to. Okay, so it's up to you. It doesn't really matter. I'm just going to erase that so we don't get confused. And what we're going to do is we're going to find our lengths. So notice this is our right triangle. So we're going to find the leg lengths here. So the leg lengths are, this is 1, 2, 3, 4, 5. And this one is 1, 2, 3, 4. So if I'm using Pythagorean theorem, I know that I need to do a squared plus b squared equals c squared. And my two legs are 5 and 4. Remember, it doesn't matter which order you put them in. So 5 squared plus 4 squared equals c squared. That's what we're trying to find. Now, usually you'd go ahead and figure that out, do that. But I want to show you something really quick. How do we get rid of a square? Don't we take the square root? You remember that from previous years? Remember the square and a square root cancel each other. So this is really the same as the square root of 5 squared plus 4 squared. Doesn't that look exactly the same as this one over here? Oh, it's amazing. That's what the Pythagorean theorem has to do with the distance formula. It is the distance formula. It's the same thing as the Pythagorean theorem. The only thing is that when you use the distance formula, you don't have to graph it first, which makes it way easier to use. So you're going to be doing it both for this lesson, but after this lesson, we're going to be just using the distance formula because it's so much simpler to use. So let's continue this problem out. 5 squared is 25, 4 squared is 16, equals c. So that's the square root of 41 equals c. Using our calculators again, we get about 6.4. So that is using the Pythagorean theorem and the distance formula to solve for the distance between 2 points. So, see if you have it memorized. Try memorizing it first, and then fill this in on your own. And remember, you need to memorize it. Okay, and that's the end of today's lesson. Thanks for watching.